Hello everyone. This SIP video is in reference to the discrete time signal processing. Here we are gonna learn some interesting thing about discrete Fourier transform and also the 4-point matrix. Now, as we all know that the discrete Fourier transform, or DFT as we commonly know, is one of the most important tools in the digital signal processing. DFT in subject of DTSP can be studied in simple three formats, which we are going to learn now. First, the DFT can calculate the signal's frequency spectrum. Basically, DFT can dissect any signal into its frequency spectrum. This is a direct examination of the information code in the frequency, phase, and any other heads of the digital transmission. For example, the human speech and hearing uses the signals with these type of encoding. As we all know that the human range of audibility, it ranges between 20 Hz to 20 kHz, and that is the frequency spectrum of the human ear. Second, DFT can find a system's frequency response from the sequence system's impulse response and vice versa. This allows the system to be analyzed in the frequency domain. Yes, the working of the frequency system varies in particular domain. In DFT, we can find how a system can work in frequency domain, just as the convolution allows system to be analyzed in time domain. Third, DFT can be used as an intermediate step in more elaborate signal processing techniques. The classic example of the FFT convolution, an algorithm for convolving signals that is hundreds of times faster than the conventional methods. Now let's talk about 4-point DFT matrix. DFT achieved by sampling the frequency domain is by given this formula, where n is the sampling period or the sampling interval. Due to the sampling in frequency domain, we observe periodicity in time domain. This is the formula because of which we get a perfect and the simplified matrix version. Now, since this is the matrix, we will check. Consider we put 0 here, value, and then we get the first row. Same if we substitute some other values instead of 0, let's say 1, then we get a different range of value. If we go ahead, the value varies and it goes up till 3. Same is the case with the 8-point DFT using the matrix method. And you have to note one thing for it. For inverse discrete Fourier transform, take the complement of the imaginary.